Hi, my name is Jessie Lim. Okay, now I will introduce the background and target audience. For coursework 3, I developed the AirMeds Real-Time Drone Operations Dashboard, a live monitoring system for medical drone deliveries across Edinburgh. It is designed for two operators group. The first is the medical dispatch coordinators who receive urgent delivery requests from hospitals or users. They need to quickly submit dispatch orders and monitor delivery progress to confirm life-saving supplies reach patients on time. Secondly, the flight supervisors are safety officers responsible for ensuring regulatory compliance. They must track all the active drone locations simultaneously, confirm flight, avoid restricted zones, and respond immediately to environmental hazards like sudden precipitation and strong wind. Previously, these operators had coursework 2's road planning capabilities but cannot visualize the live operations. They could calculate optimal paths but had no way to see where the drones actually were, whether deliveries completed successfully, or if safety issues emerged mid-flight. So my dashboard filled these operational gaps. Next, I will talk about why I built this dashboard. So the problem is straightforward but significant. In coursework 2, it provides road planning capabilities but does not offer operational visibility. So imagine running a medical emergency drone service where you can calculate the perfect flight path, but you have no idea where your drones actually are right now, whether they are stuck in bad weather, if they have completed their deliveries, which drones are available for the next emergency, whether flights are violating no-fly zones. So this creates two critical operational failures. First, no operational visibility. Second, no flight oversight. So first, no operational visibility. The operators cannot monitor drone live location, progress, track multiple deliveries simultaneously, or confirm drone status and delivery completion. So when hospital call asking where is our urgent medication delivery, there is no way to answer them. Second, no safety oversight. So there is no weather monitoring to hazard alerting, so operators cannot access whether drones are encountering dangerous conditions such as strong wind and precipitation that requires human intervention. Now let me show you the solutions to the problem stated. Now I'll submit a new medical dispatch list through the input panel. I could just type in manually here or click this show example button and load this example. And the system will validate the JSON structure, checking for the required fields such as the delivery ID, the capacity, and the delivery destination coordinates. So I'll just add batch and calculate path. And immediately you can see in the active flight panel the batch details, including how many drones is used. Drone 1-1 means in batch 1, drone 1 is handling it. And what gets more interesting is that when I zoom in, I can see the detailed real-time flight animation, so I can know where the drone currently is. Now it is approaching to one delivery point, so it changes. Yeah, it's delivering now, so it changes to the delivery icon, and then it continues to the next delivery point, so it changes back to the flying icon. When I hover over the drone, I can also see the drone number and the status. When I click on the delivery point, I can also see the delivery point details, including delivery ID and the coordinates. And the bigger circle here indicates the service point. When I click on it, I can see the batch details. And in the current status panel, I can see the progress of the drone in percentage. This percentage is calculated through the index of the current coordinate divide by the total number of coordinates times 100%. And as you can see, the drone is returning, so it changes to the return icon. This dash line indicates the returning path, and it completed, so it changes to the completed icon. I can also add multiple batches to comply with real-life situation. So again, I'll just load this example in, and I'll just add another batch that I prepared beforehand. So similarly, you can see the batch details in the active flights. You can see batch 2 and batch 1. So when I zoom in, you can see 3 drones flying. Yep. And I just want to emphasize that different batches will have different colored flight paths just to differentiate the batches. Drone 2-3 means drone 3 currently handling batch 2. And then also notice that the busy drones are removed from the drone availability list so that the operators can clearly see which drones are available, just in case they need to use the drones for manual deliveries. Okay, now I will enable the weather overlay feature. And as you can see, there are some blue grids and some gray grids. When I click on one of the blue grid, you can see that there is 0.1 mm of precipitation. And when I click on one of the gray grid, there is no precipitation. These colors of the grid is actually determined by my front end weather overlay.jsx, where different wind speed and precipitation value gives different color to the grids. Now I would like to show you what will happen if I add a batch. for the drones to fly in the precipitation area. As you can see here, a precipitation hazard alert is generated where drone 2 handling batch 1 is currently in a 0.1 mm precipitation, and it is time-stamped and updated every 10 seconds, as you can see here. The system continuously check the drone's coordinate against the weather cells and generate timestamp alert when wind exceed 19 mph or any precipitation is detected, because it is both these conditions makes drone flights dangerous, and it may cause the drone to damage as well as causing the medication to not be able to be delivered promptly. Hence, these alerts will allow the operators to be aware of this condition and hence carry out prompt human intervention by maybe rerouting or delay or delivering the medication in other means, so that the drones doesn't get damaged and the patients get the medication on time as well. Lastly, I will explain why I chose these specific tools for my implementation. So for front end, I selected React 18 because its component-based architecture allowed me to build each operational panel as an independent reusable module. The automatic UI updates support real-time changes. Besides, Leaflet.js was the obvious choice for mapping because it is lightweight and has excellent support for custom markers and overlays. And it has also a lot of built-in features such as set center and set zoom for programmatic control. For back-end integration, I use Vite's proxy configuration to route API calls from the front-end development server on port 3000 to the Spring Boot backend on port 8080, and this reduces the CORS issues. I also used OpenMeteor API to retrieve real-time weather data, and I used it because it is free and it is very convenient and simple to use. I also use HTML and CSS to style my web page because it is very flexible and straight to the point. It's very easy to use. I also use Git for version control, so I can track my changes. I can save all my files, and if there's any issues, I can call back my previous version easily. So this is basically my project. Thank you for listening.